Today, we are going to travel from the edge of the continent to the deepest part of the ocean. Imagine that you're standing on a beach, you walk into the sea. Initially, the water becomes deeper very gradually. Then, suddenly, the sea floor begins to fall steeply. After that comes a gentler zone, then a vast flat plain, and finally, somewhere far below, the deepest trenches of the earth. Good day, my dear aspirants. Welcome back to Decode UPSC. So, with this, we understand that ocean floor is not flat. It has its own mountains, valleys, plains, plateaus, and depressions. And today's topic is extremely important because it connects physical geography, plate tectonics, ocean currents, climate, fisheries, and navigation. So, by the end of this class, you should be able to visualize the entire ocean floor from continental shelf, continental slope, continental rise, abyssal plain, and the various minor features. Okay, let's begin. Ocean relief. First, what is meant by ocean relief? It refers to variations in the topography of the ocean floor. Okay, so ocean floor is not same. Ocean floor is not monotonous. It refers to the variations in the topography of the ocean floor. Just as lands have mountains, plateaus, plains, the ocean floor also has highly varied relief features. Okay, highly varied relief features. These features are produced by the combination of action of tectonic plates, volcanic activity, erosional and depositional processes together which are acting together. So it occurs because of tectonic plates, volcanic activity, erosional deposition, all these kinds of activities combine together and form ocean relief floor. Okay, so for UPSC, we have to divide them into two major categories like major relief features, okay, and minor relief features. So these major relief features are continental shelf, continental slope, continental rise, deep sea, abyssal plain, ridges, hill mountains, guyards, trenches, canyons, fracture zones, island arcs, atolls, coral reefs, banks, and shoals. So these are the minor as well as major relief features. Okay, so do not just simply memorize it. Okay, so always connect the features with the process behind it. For example, trench, think about convergence, mid-ocean ridges, think about divergence, seamount, think submarine volcanism, Guyot, think about erosion and subsidence, atoll, think about coral growth and subsiding volcanic activity. Okay, so coming to the first relief feature we will be talking is continental shelf. Continental shelf. Now imagine you are moving away from the coast. Okay, you are moving away from the coastal area. Okay, so and then the continental shelf is the gently sloping. It is the gently sloping. Okay, so it is the gently sloping submerged extension of continental plate. See, here is the continental plate and it is the extension of continental plate. In simple words, the continent does not suddenly end at the coastline. It will not suddenly end over here. Okay, so it gets extended. Okay, it continues below the sea level as a continental shelf. It is occupied by relatively shallow seas, gulfs. Okay, the gradient is generally 1 degree or less. The gradient is generally 1 degree or less. Okay, clear? So these marks. So at this point comes an important point is that the shelf does not continue forever, and these also have to end at one point. At certain point, there is a relatively abrupt break, which is called as shelf break. Okay, so continent is ending as a continental shelf, and continental shelf has to also take break, that is shelf break. So this marks a transition towards continental slope. Continental slope. So how is this continental slope formed? How is this continental slope formed? According to the material, important factors include submergence of part of the continent. Okay, submergence of the part of the continent, relative rise in the sea level, and also sedimentary deposits from the rivers. So these three leads to the formation. Okay, so submergence of part of the continent, relative rise of the sea, and sedimentary deposits brought by the river. So now, why should UPSC aspirants care about the continental shelf? Because continental shelves are extremely economically important. They contain large sediments and are important source of petroleum, natural gas, okay, and other marine resources, okay, and other marine resources. So they are the sources of petroleum, natural gas, as well as other marine resources. So remember, continental shelf is shallow extension of continent. It is an extension of continent, and it has major economical importance. It has major economical importance. Is it okay? So next, moving forward, this is the initial starting point of our journey towards understanding the ocean. Next, shelf, moving towards the shelf, you will understand its width, depth, as well as importance. The average width of continental shelf is around 70 to 80 kilometers, almost absent along steep coast. Okay, so example Chile. Okay, so but it varies dramatically. Along steep coast, the shelf can be almost absent. Okay, so for example, it mentions that Chile doesn't have any steep coast. On the other hand, Siberian shelf, Siberian shelf is the widest in the world, approximately 1500 kilometers. Siberian coast is the widest along 1500 kilometers. Okay, and again, the depth also varies from 30 meters in some regions. In 30 meters in some regions to 600 meters in other regions. Now look at the type of continental shelves. I mentioned here shelves. Okay, so we have glacier shelves like Greenland, coral reef shelves, Queensland, river mouth shelf, Nile Delta, Dendritic Valley Shelf, Hudson River Mouth. Okay, so Dendritic Valley Shelf, Hudson River Mouth. Now let us understand the economical significance. The continental shelf, okay, contains some of the world's richest fishing grounds. It is also associated with petroleum, natural gas, and according to material and polymetallic magnesia study. So, if UPSC asks, continental shelves are economically important, your answer should immediately include it consists of fisheries, hydrocarbons, marine mineral resources. Which shelf is the wildest? For us to understand, for us to remember, which shelf is the widest? Siberian shelf. Okay, so which region can have an almost absent shelf because of the steep coast? Chile. Okay, so good, keep these examples in your mental map. Okay, so they should be remembered for longer tenure of time. Okay, so they should be kept in your mind for longer tenure of mind. So next again, so we have continental slope. If the continental slope is like a gentle ramp, the continental slope is like a much steeper descent. It connects the continental shelf to the deeper ocean basin. Its gradient is approximately 2 to 5 degrees. Its gradient is approximately 2 to 5 degrees, and the deep range is between 200 to 3000 meters. 200 to 3000 meters. Now, one statement here is extremely important. The continental slope marks the true geographical edge of the continent. Okay, so this is the true geographical edge of the continent. So another important association is submarine canyons. Submarine canyons and upper reaches of trenches, upper re- ranges of trenches may be associated with this region. So remember the sequence visually. Shelf is very gentle, then slope is steep. Shelf is gentle, slope is steep. Okay, so is it clear till here? So we will go very slow because this topic is very complicated to understand. Now, after descending down the continental slope, what happens is the steep slope continue forever So does everything continue forever? No. So gradually the steepness decreases. Gradually it decreases. The continental slope as well as abyssal plain. Okay. So how it is formed? A major process is the deposition of sediments transported down the continental slope. So, whatever the sediments brought by the continental slope will be deposited here. Okay, clear? So, this is an excellent conceptual connection for UPSC. Shelf is shallow, slope is steep, rise is sediment rise, okay, so planes are flat. Say it once again: shelf, slope, rise, plane. Shelf, slope, rise, plane. So this sequence is actually fundamental in nature. Next, moving forward, deep sea or abyssal plain. Now we reach one of the most fascinated regions of the ocean floor, the abyssal plain. Abyssal plains are gently sloping, okay, and extremely flat areas. They are extremely flat areas of the ocean basin floor In fact, it describes them as the flattest and smoothest regions on the earth. So, why are they flat? Because the sediments, okay, the sediments gradually deposit. The sediments gradually deposits, okay, and there is irregularities of underlying ocean floor. These sediments include the materials like clay, slit, and other fine grained elements. Okay, this abyssal plain covers nearly 40% of the ocean floor. Okay, so according to our understanding, the deep range is approximately 3000 to 6000 meters. 3000 to 6000 meters. So do not imagine the ocean floor has completely rugged. It is not completely rugged. Large areas are actually remarkably flat because sediment has covered the irregular topography. Clear? So here for a key takeaway is abyssal plains are deep, flat, sediment covered. Okay. So are deep in nature, they are flat in nature, they are sediment covered. So next, moving to ocean trenches. Now we will discuss about one of the most dramatic features of the ocean floor. They are ocean trenches. Okay, so they are ocean trenches. They are steep sided and narrow depressions. They are the deepest part of the oceans. Okay, they are the deepest part of the ocean. And here is the most important conceptual point: is that trenches are associated with convergent plate boundaries. So we know the plate tectonics theory. So they are associated with convergent plate boundaries. They are tectonic features formed where ocean plate or ocean plate meets continental plate. Clear? So if an ocean plate is meeting the ocean plate, okay, so if an ocean plate is meeting the continental plate, then it forms. Okay, so therefore when you hear convergence, subduction, and trench, the connection should be automatic. Trenches may lie along the fringes of abyssal plain and often run parallel to the fold mountains or island arcs. Okay, so here it identifies that Mariana Trench, Pacific Ocean near Guam, is the deepest known trench, over 11 kilometers. Okay, so it is associated with active volcanoes, deep focus earthquakes. Example in Japan, key evidence for plate movement. 57 deep were explored so far, 32 in Pacific Ocean, 90 in the Atlantic Ocean, and 6 in the Indian Ocean. Okay, clear? So here UPSC can trap you if there is a statement the Mariana Trench is located in the Atlantic Ocean. Where it is located? In the Pacific Ocean. Immediately we have to reject it, stating it is located in the Pacific Ocean. Okay, so next, clear? So the Pacific Ocean actually dominates, and conceptually, this makes sense when we connect the Pacific with the extensive tectonic plate activity, yes, so there is more plate tectonic activities in Pacific Ocean, so this can be connected with this. Okay, so next moving to, now we move from convergence to opposite process, divergence. Okay, so when in the plate tectonics theory, we know the concepts of convergence, we know the concepts of divergence. Okay, the mid-oceanic ridges are mid-oceanic ridges are submarine mountain system formed at divergent plate boundaries. So remember, trench is convergence, ridge are divergence. Ridges are divergence. This contrast is extremely important. Okay, so this describes the mid-oceanic ridges has two mountain chains. Okay, so they are two mountain chains separated by large central depression. So they are separated by large central depression. So some peaks can rise around 2500, some peaks can rise around 2500 meters, some rise above the ocean level. Example, island in the mid Atlantic ridge, total length is 7500 kilometers, the largest continuous mountain system on the earth. Okay, approximately 7500 kilometers, so the largest continuous mountain system on the earth. Okay, clear? The best example we can quote here is that Iceland, which is associated with the mid Atlantic ridge. Another amazing fact is that the total length of the ridge system is 7500, making it the continuous mountain system on the earth. So, whenever UPSC asks why are new crustal processes associated with plate separate vision, think it is about mid oceanic ridges. Next, moving to seamount Seamount and Guyot. Don't confuse them. Now let's understand two important features that UPSC loves to confuse. Seamount is a volcanic mountain with a pointed summit. Okay, with a pointed summit rising from the seafloor that doesn't reach the surface. Okay, it is not reaching the surface, and it can be 3000 to 4000 meters tall. 3000 to 4000 meters tall. Example, Emperor Seamount Chain. Example can be Emperor Seamount Chain Pacific. Next again, Gayat is a flat. Okay, it is structural difference. It is a flat. It is a pointed structure. The summit can be truncated by erosion or wave action before subsidence. Okay, so might be a wave action or because of erosion this has formed. So both are extremely common in the Pacific Ocean with an estimated approximately 10,000 seamounts or kayaks are present. Okay, the easiest way to remember is seamount is mountain like pointed, Guyot is flat top structure. So if UPSC confuses a Guyot has a pointed structure and has never reached the sea level, which means the statement is wrong. It notes that seamounts and Guyots are especially common in Pacific Ocean. Clear? Okay. So next again, moving forward, submarine canyons. Submarine canyons. So they are deep, steep-sided valleys that cut into continental shelf and continental slope. So some can be comparable to scale in the major land canyons. Okay, so here we have three broad types. First one, small gorges. Okay, so at the shelf edge, is it okay? And second one, canyons at river mouth extending over the shelf. Example, Zaire, Mississippi, Indus, and dendritic canyons which cut deep into the shelf as well as slope. Okay, the Hudson Canyon is best known submarine canyon in the world. Example, the Hudson Canyon is the best known submarine canyon in the world. The largest canyon occurs in the Bering Sea of Alaska, bearing all these canyons. Okay, clear? Is it okay? So now connect this with the canyon extending from the river mouth canyons. Now coming to atoll, it is a beautiful story. It is a beautiful story. Okay, so now we have an interesting, beautiful story. An atoll is an island in a tropical ocean made of coral reefs, okay, surrounding the central depression called lagoon. A lagoon may have different types of water and may connect to an open sea. Now comes the Darwin's famous explanation. According to Darwin's, subsidence theory, a volcanic island gradually subsides, okay, but corals continue to grow upward. The sequence is like fringing reef, barrier reef, and atoll. Eventually, volcanic island may become completely submerged while the coral structures remains around the lagoon. Okay, so coral structures remains along the lagoon. So this is the favorite conceptual understanding for UPSC. Okay, so fringing, barrier, atoll. Fringing, barrier, atoll. We have to remember subsistence of the volcanic activity plus upward growth of the coral. Clear? Is it okay? So next again, moving to the three terms which are often confused. Bank is the flat topped elevation. It is a flat topped elevation on the continental margin. Okay, so it is shallow but navigable. It is shallow, but it is navigable. But banks are associated with highly productive fisheries. They have huge fisheries. Example: Dogger Bank, Grand Bank. Okay, so shoal is a detached, shallow elevation that projects close to the ground. So which is dangerous for navigation. Okay, so reef is mound. Okay, reef is mound or rich of the organic, especially coral deposits. Reefs can also be hazardous for navigation. Okay, so large reef example can we see at Queensland, Australia. Okay, so for us to understand, banks are for fishing, shoal are shallow, dangerous, reefs are coral structures. That's it. Keep it very simple. Okay, so now the very big question is that why should a UPSC aspirant study all this? Because ocean relief is not merely a diagram in geography textbook. Ocean floor topography, it affects the movement of seawater and therefore influences the ocean currents. Ocean currents then affect climate, weather patterns, and oceanic conditions. Ocean relief also directly influences navigation routes, fishing zones, and marine resource distribution. So the chain is quite simple. Ocean relief controls the motion of the seawater, okay, shaping ocean currents. Then these currents in turn drive major variations in the both oceanic as well as atmospheric condition, climate, weather patterns. The bottom relief of ocean directly influences the navigation routes. Clear? Is it okay? So now for rapid revision. So let's revise quickly. Continental shelf is gentle, shallow extension of the continent. Continental slope is steeper descent and geological edge of the continent. Continent rise is gentler depositional transitional zone. Abyssal plain is deep, extensive, and extremely flat sediment covered plain. So minor features include trench, deep depression at the convergence plate boundaries, mid-ocean ridges, submarine mountain system at the divergent plate boundaries, seamount, pointed volcanic mountain below the sea level, guyots are flat top the sea mountain, submarine canyons are deep valley cut into the shelf and slope, atolls are coral reefs surrounding the lagoon. So banks are shallow elevation, often productive for fisheries. Shoal is a feature dangerous for navigation. Reefs are organic coral deposits, also they are navigational hazard. Okay, so we have few NCQs. Consider the following statements. The continental shelf together covers around 7.5 percentage of total area of the oceans. Yes, the Siberian shelf in the Arctic Ocean is the widest continental shelf in the world. Yes, the continental shelf is primary source region for polymetallic nodules. No. Okay, 1 and 2 are right. Next, coming to the continental slope marks the geological edge of the continent. Yes, the gradient of continental rise is steeper than that of continental slope. No. The next again, consider the following statements. Oceanic trenches are formed mainly due to convergent plate boundaries. Yes, the Mariana Trench, the deepest known trench, is located in the Atlantic Ocean, in the Pacific Ocean. More oceanic deeps have been explored in the Pacific Ocean than the Atlantic and Indian Ocean combined. Yes. Next, consider the following statements. Mid-oceanic ridges are formed at convergent plate boundaries. So we have already seen they are divergent plate boundaries. Iceland is an example of mid-oceanic ridge rising above the sea level. Yes. Next again, consider the following statements. A Gayat is a seamount with a pointed summit that has never reached the sea level. Okay, false. It is okay. Seamounts and Gayats are especially common in the Pacific Ocean. Yes, according to Darwin subsidence theory, an atoll represents the final stage after a volcanic island fully submerges beneath the coral growth. Yes. Next, again, consider the following statements. A shoal is generally considered safe for navigation due to deeper depth, greater depth. No. Banks are often associated with some of the world's most productive fisheries. Yes. Next, distinguish between the major and minor relief features of the ocean floor. Discuss how the study of ocean reliefs is significant for climate, navigation, as well as fisheries. Okay. Here for us to understand, what you have to do is that, so today we discussed all the major features, today we discussed all the minor features. So all these, try to write them, and wherever navigation is present, where the navigation is not present, how the climatic conditions influence because of these major and minor relief features. So these all have to be discussed in your answer. Okay. So friends, today we traveled from continental shelf to deepest trenches, and most important thing is not just to memorize the names, visualize the ocean floor. From the continent, you move across the shelf, slope, rise, and abyssal plain, and then understand the special features like trenches for convergence, ridges for divergence, seamount for submarine volcanism, Guyot for erosion and subsidence, atoll for coral growth around a subsiding volcanic island. So, if you remember the process, you can handle both prelims as well as mains explanation. The ocean floor is not a hidden geography, it is an active geography. It records tectonic movement, volcanic activity, sedimentation forces, and ultimately it influences the climate, navigation, and fishery. So, don't study this as a list of landforms actually. Study it as a story of Earth beneath the ocean. If you found this class useful, revise the MCQs once again and try to answer mains question. Okay, so clear. Thank you for watching. This is Decode UPSC. Unlock your potential, decode your future. See you in the next class. Thank you.